So, do you remember that in our last class, what we did? We solved undamped wave equation, and that was like this: a square. So that was a square uxx is equal to utt. Okay, a square uxx is equal to utt, where the value of x is between sum 0 to L and the value of t is greater than 0. So this case we solved. If you remember, this case we solved, and for this case we solved that if the ends of that strings are not moving, and suppose this is the vibrating string but the ends are not moving, ends of the strings are not moving, then u of x comma t was given by summation n is equal to 0 to infinity an cos an pi t by L plus bn sin an pi t by L into sin n pi x by L. Okay, this was the solution that I told you. I derived it in last class, and then the values of an and bn, if you remember. So the values of an and bn were ux comma 0 was some fx, utx comma 0 was some gx, and I told you that the values of fx and gx can be written. Correct? The value of fx and gx can be written to calculate the values of an and bn. So that I could told you, that is actually the concept of Fourier series. But even if we don't know the Fourier series, I told you how to derive that. Okay, so this was the first thing which we did for one dimensional undamped equation. Okay, so now there is a special case when this gx is equal to 0. When this gx is equal to 0, then there is a special case, and we can solve the value directly by using this special case, and that is known as D'Alembert's form. That is known as D'Alembert's form, and the D'Alembert's form says that ux comma t can be written directly if fx is known and gx is not known. For this particular case, it will become half of f of x plus at plus f of x minus at. And I hope you understand the meaning of small f. The meaning of small f is very clear, that is initial displacement. What is the meaning of small f? That is initial displacement. Correct? So note down this. So let me tell you a question on this first, and then I will discuss a question on the first case. And the question on this is, suppose for such a one dimensional undamped oscillator, okay, with uh, with the strings like this, they are not moving, because with that only we reduce two constants. So with such a string, suppose the value of fx is given, that is equal to e to the power minus x square, and this is the wave equation, and the value of gx is given in this question is equal to 0, and they have suppose asked for the solution. So what will be the solution? U of x comma t is equal to half of e to the power minus x plus at square plus e to the power minus x minus at square. Correct? So u of x comma t is equal to half of e to the power minus x plus at square plus e to the power minus x minus at का square. So this is the solution of this case when the initial condition was given. Fx means what was given? Ux comma 0 was given. Fx means ux comma 0 was given. Correct? So you remember this, that if in any problem, suppose let me take another problem in which fx is given, suppose sine of x, it is given like this, then what will be the solution? Ux comma t is equal to half sine of x plus at plus sine of x minus at. This will be the solution. Correct? And suppose in this case also the gx was given to be 0. The gx was given to be 0. So have you understood this part? Tell me.
Yes, sir.
Is this
Yes, sir.
so? This is D'Alembert's part. This part is known as D'Alembert's part. So let me now take up another case. So please see this now. Now again, in my next question of this one-dimensional oscillator case, undamped oscillator case, we have been given that uh, in the question it is given that 9uxx is equal to utt, and it is between 0, x and 5, and u of 0 comma t is equal to 0, u of 5 comma t is equal to 0, and x is between this t is greater than 0, and also u of x comma 0 is equal to 4 sine pi x minus sine 2 pi x minus 3 sine 5 pi x. Okay, and u of t x comma 0 is equal to 0. This is the question. Okay, this is the question, and suppose u of x comma t is equal to question mark. Correct? So now this is also belonging to the same form. I can solve it using D'Alembert's, but let me solve it using other way. D'Alembert's way will be for your homework. Solve this using D'Alembert's method as a home exercise. Okay, and let me solve this. I will write it like this. The value of a is 3. Can you see that? And the value of L is 5. Can you see that for this equation? And so u of x comma t will be equal to summation समझ आ रहा है ना?
Yes, sir.
u
Yes,
of
sir.
x comma t is equal to summation n is equal to 0 to infinity, and then an cos 3 pi x by L plus bn sin 3 pi an and also an wait an pi t by L sin an pi t by, and what is L? L is 5 into sine of n pi x by L. This is the solution, and this term goes to 0. Yes, because this is gx and the value of gx is 0. So bn is calculated using gx. You can see मैंने आपको बताया हुआ है कैसे कैलकुलेट करते हैं. तो उस हिसाब से ये जो bn की वैल्यू है that will become 0, and I will use this condition. Let me use this condition. So it will become 4. इस समय मैं t is equal to 0 रख रहा हूं. 4 sin pi x minus sin 2 pi x minus 3 sin 5 pi x is equal to, and this side it will become an, because t is equal to 0, and summation into this. So it will become summation n is equal to 0 to infinity an sin n pi x by 5. Correct? Now compare the coefficient. यहां पे सबसे पहले है पाई एक्स. यहां पाई एक्स कब बनेगा? जब n इज इक्वल टू 5 होगा. इससे पता चलता है कि a5 की वैल्यू 4 है. यहां पे 2 पाई एक्स कब बनेगा? 2 pi x will be formed when n is equal to 10. So that means a of 10 is minus 1. And 5 pi x, 25. Okay. And what is value of a of 25? That is equal to minus of 3. Correct? So all other coefficients will be 0 because there is no comparison on the left hand side. So now we can write the solution of this equation as u of x comma t is equal to 4 times cos 3 pi t into sin pi x minus cos of 15 pi t sin 2 pi x, again minus 3 and 25 रखो तो cos of last one is 25. This one is 10. So this one will be 6, na? Just wait. First one is 5. So it is cos 3 pi t and sin pi x. Then you have minus 10. So cos 6 pi t sin 2 pi x. Then 25 minus 3 cos 15 pi t sin 5 pi x. This is the solution. So ये I have calculated using proper boundary condition. I have calculated it using proper boundary condition. Tell me if this is clear or there is any doubt. You can ask if you feel there is any doubt.
Sir,
Hmm.
sir, please tell why Bn tending to 0?
How you calculate Bn?
Integration gx.
तो gx 0 हो गया तो Bn क्या होगा?
Okay, sir.
So why we compare this value ux0 to this an sin and pi x by 5?
Why?
Yes, sir.
Why is a very bad question. It is no question. Why we are solving it? Why we are writing the question?
So actually, so I didn't get it actually.
No, तो why is not a question ना भाई. बाउंड्री कंडीशन लगा रहा हूँ and you are asking why. तो इसका क्या आंसर दे सकता हूँ बताओ.
Yes, sir. Actually, now it should be we have to compare like an cos 3 and pi t. I
Sorry.
sorry, sir. Actually, I got confused. We have to compare with the x. Sorry, sir.
No problem. So just I have applied the boundary condition. T is equal to 0. So when t is equal to 0, it will become ux comma 0. So I have written like this, and then right hand side I put t is equal to 0. This term will be gone anyway. So this term will become an, and t is equal to 0. This will become 1. So this will be multiplied just sin n pi x by 5. Now this is infinite series, but only few coefficients will exist, and that I have chosen according to this. When pi x will come, when 2 pi x will come, when 5 pi x will come. Only 3 terms will exist. Then I have got the values and I have substituted back here to get this value. Please see this. Okay. So for understanding purpose, this was very nice question. Okay. So now let me take another question in which the boundary condition is different. So I will take another question in which the boundary condition is different, and that is 9 of uxx is equal to utt and this is x is like this and t is greater than 0. Okay, and the values are like this: u of 0 comma t is 0 and u of 5 comma t is also 0. This means that the ends of the strings are tight, they are not moving, and then ux comma 0 is 0 and ut uh, x comma 0 is equal to 5. This is the question. Is equal to 4. Is equal to 4. This is the question. So now you can clearly see this is fx, which is equal to 0 in this case, but gx is finite, that is equal to 4 in this particular case. The value of gx is equal to 4. Correct? Now, can I write a is equal to 3 and l is equal to 5 and also an is equal to 0? Can I write this?
Yes, sir. Fx is 0.
Yes, sir.
This time fx is 0. So an is equal to 0 and I can immediately write the ux comma t, that is given by summation n is equal to 0 to infinity bn sine n pi x sine a n pi t by l sine n pi x by l. Okay, correct? Now you know how to write. I have told you the formula also, but let us derive that, because if we forget how we will derive utx comma 0. So first of all, get utx comma t, that will be summation n is equal to 0 to infinity bn 3n pi by 5 cos 3n pi t by 5 sine n pi x by 5. This is the value of ut, correct? And then ut x comma 0 is equal to summation n is equal to 0 to infinity bn 3n pi by 5. This will become 1 and sine n pi x by 5. Fine. And bn is equal to so let me write it like this. What is utx comma 0 given? 4. So it is given 4. यहीं पे लिख देता हूँ. 4 is equal to this. So 4 के लिए this is infinite Fourier series for 4. 4 is equal to this. But then I am interested in bn. I want this bn. So how to get that bn? I told you. 4 into sine of n pi x by 5 integral 0 to 5 dx is equal to bn 3n pi by 5 sine square n pi x by 5 dx 0 to 5. Correct? Is that okay? And this is going to give, so now we have actually got this value bn, so this will become upper limit by 2, so this will just become 5 by 2 Okay, and what will be the value of bn? That we can see the value of bn will become, so this will become 2 by 5 will be multiplied that side, so क्या बन जाएगा, this 5 by 2, so 5 and 5 will cancel and 2 will be multiplied that side, so what it will become, 8 by 3 and pi, करेक्ट है भाई.
Yes, sir.
साइन का क्या हो जाएगा, माइनस कॉस n pi x by 5 over n pi by 5, 0 to 5. So this will become 8 over 3n pi minus, and 5 will go there here, 5 8 40, and n square pi square, and when I put 5 it will become minus 1 to the power n minus 1. So it will become 80 by 3n square pi square for n is equal to 135 dash dash dash, and 0 for n is equal to 246 dash dash dash. This is the value of bn.
सर ये 4 = 2 वाले स्टेप के बाद क्या किया?
दोनों तरफ साइन एन पाई एक्स बाई 5 से गुणा कर दिया और लिमिट में इंटीग्रेट कर दिया. ये मैंने आपको कोफिशिएंट डिराइव करते समय सिखाया हुआ है कल, ए एन और बी एन निकालते समय, जब मैंने एफ एक्स
हाँ,
और जी एक्स के
यस सर.
टर्म में लिखा. तो यहाँ पे लिख लो, मल्टीप्लाइंग बोथ साइड्स बाय साइन एन पाई एक्स बाय 5 एंड इंटीग्रेटिंग इन द गिवन लिमिट. और यहाँ समेशन लगा हुआ है, आप ये पूछ सकते हो कि बाकी टर्म्स कहाँ गए, बिकॉज आई हैव ओनली टेकन nth टर्म, because all other terms will become zero when you will multiply it by sin n pi x by 5, because you know sin m sin n, that integration becomes 0.
यस सर.
That will survive only they are equal. So now we have everything. If you allow me to erase this part, I will write, no, I can write here also. So see, now our solution will be ux comma t is equal to summation n is equal to 135 to infinity, correct? This is our solution, and bn, which is given by 80 over 3 n square pi square into sine of 3n pi t by 5 into sine of n pi x by 5. This is the answer. So solutions of partial differential equations are mostly in the form of infinite series. They are not simple solutions like ordinary e to the power x, sine x, something like that, okay? They are in the form of infinite series most of the time. So you can open this and you can write few terms if you want. Please see this, and if there is any doubt, feel free to ask. So would you like to, can I erase this last one?
Yes, sir.
So if I erase this, then I can actually write the solution in the infinite series form like this: u of x comma t is equal to 80 over 3 pi square into the first term 1 sine of 3 pi t by 5 sine of pi x by 5 plus sine of 3 square sine 9 pi t by 5 and sine of 3 pi x by 5 plus dash dash dash. So such type of series you can write. This is the infinite series solution of this equation. Okay, so if you have written it completely, so you can see here that Fourier series actually we are doing without telling you. मैंने तो डायरेक्ट वो मेथड कर लिया जो Fourier series में यूज होता है, but this Fourier series is playing very important role here in the calculation. Fourier series is playing very important role, correct? So you can see that just new boundary conditions may be given and you will have to solve it like this. New questions may be formed. So to understand, this much is enough. So let me erase this. Okay. So I took undamped wave equation and you have seen that the solutions are in the form of sine and cosine, which is not the realistic case. In real life, what will happen? So I should write the general wave equation. The general wave equation, and that is given by some a square uxx plus some function of x comma t is equal to utt plus gamma times ut plus k times u. Now you can see the same factors working here. They were working in the harmonic oscillator case also. So same factors are working here. This is damping factor and this is restoring factor. I told you that time also. It is going to be very important. And this F is some external force which will be different in different case. External force. So you can imagine how difficult it would become if you have a complex profile of external force, and then gamma is also suppose a complicated, not a constant but a complicated function, and k is also like that. So such wave equations becomes very complicated, and the only method that we can pursue is the methods of numerical techniques that works in this case. Okay, but we can, just to understand, I can give you a glimpse of a very simple case, which is one dimensional wave with damping, just to tell you how the damping works. Only damping factor I will take, no other factor I will take. Okay, so what will happen? A square uxx will become equal to utt plus gamma times ut. This is the equation that I want to address. Okay, so the method is a well-known method. You know that method is known as the variable separable method. So let us apply that variable separable method. What will happen? So now you are also aware of ना कि इसको कैसे solve करना है. देखो भाई, so u of x comma t is equal to capital XX into capital TT. Correct? And if you substitute here, you will get a square tx double dash is equal to xt double dot plus gamma xt dot. Dot is visible. Now immediately you can guess what is going to happen. Simply a square uh, double x double dash. So I am dividing it by x and t. It will become equal to x and t I am dividing. So t double dot by t plus gamma t dot by t. Okay, and a square को भी इस साइड भेज देते हैं. So a square is here, just to have a favorable form, and this is equal to minus lambda square. एक बार आप अगर प्रैक्टिस कर लो तो it becomes very very easy. So x double dash plus lambda square x is equal to 0 is one equation, and t double dot plus gamma t dot minus lambda square a square t is equal to 0 is another equation. So these are the two equations that need solution. First solution is so simple, x becomes a cos lambda x plus b sin lambda x, correct? And for second equation, so can you see these are differential equations of second order? So we can't solve partial until unless we are very very absolute, we have absolute knowledge of ordinary differential equations. Okay, so that because I told you I will be using those equations here like ABCD, यहाँ पे बहुत जल्दी जल्दी यूज होने वाली हैं, तो इसलिए ऑर्डिनरी डिफरेंशियल इक्वेशन की जानकारी होना बहुत ही आवश्यक है. ठीक है, so let me write this, the solution of this equation also. So that will become some d square plus gamma and d minus lambda square a
प्लस
square.
लैम्डा
सर प्लस
स्क्वायर
लैम्डा स्क्वायर आएगा.
कहाँ पे प्लस?
सेकेंड इक्वेशन प्लस लैम्डा स्क्वायर ए स्क्वायर टी.
प्लस लैम्डा स्क्वायर ये
यस सर, यहीं पे. यस सर, प्लस
बिकॉज
आएगा.
लैम्डा इज
प्लस लैम्डा स्क्वायर, राइट. ठीक है, so this will become d square plus gamma d plus lambda square a square is equal to 0, and its roots will become minus gamma plus minus under root gamma square minus 4 lambda square a square over 2, correct? So these are the roots, let us write them as alpha and beta. Alpha is equal to the first root and beta is equal to the second root. So what will be the solution of capital T? That will be equal to e to the power alpha t and c uh, so let me write these two solutions as m1 and m2, because we don't know uh, whether they are whether negative is here or not. So I will write capital T is equal to c1 e to the power m1t plus c2 e to the power m2t, and m1 and m2 are two roots. First root is with positive sign and second root is with negative sign, and product of this is our solution. So what is our solution? The product. So u x comma t is equal to a cos lambda x plus b sin lambda x into c1 e to the power m1t plus c2 e to the power m2t. This is the solution. After this you will need four boundary conditions, four boundary or initial condition, ठीक है, to solve the equation. Tell me if this much is okay. यहाँ तक कोई डाउट हो तो बताओ। ओके, ठीक है ना। तो अब इस पे
Yes,
भी
sir.
हम लोग को प्रॉब्लम्स करनी पड़ेगी, फिर ऐसे ही लैप्लास इक्वेशन सॉल्व करेंगे। सो ऐसे ऐसे इंपॉर्टेंट इक्वेशंस पार्शियल डिफरेंशियल इक्वेशन की करेंगे। ठीक है, चलो ओके, थैंक यू।
Thank you, sir.
थैंक यू सर।
Thank you, sir.
Thank you, sir.
थैंक यू।